So in today's lesson, we're going to utilize our understanding of solving quadratic equations by applying it to a word problem. And so I would highly recommend that those of you taking the grade 11 functions MCR 3U course, the university pathway course in grade 11, that you work through this optional section. So let's read through the problem. It says the path of a stone thrown into a ravine is modeled by the quadratic equation, and here it is. Where D represents the distance in meters traveled horizontally, and H represents the height in meters above the surface of the river at the bottom of the ravine. So we can see how it's reasonable to think that the pattern, the flight pattern of that stone down the ravine is going to resemble that of a parabola. It also makes sense that when we look at our quadratic function, that the value of a would be negative because, of course, our parabola would be opening downward. So now how are we going to solve this? Well, we're asked to find out how far the stone travels horizontally. And so in this equation, what we're looking for is distance, which is represented by the variable d. So if we solve this quadratic equation, we will be solving for the variable d, and thus we'll have that horizontal distance. So this is no different than what we've seen in some of our other problems where we're solving quadratic equations. It's just that the value of what we solve for happens to have meaning in a way that is different than maybe some of our graphical representations. I'm just going to make this a little bit smaller so that I can have a little bit more room to display my solution. So as always, with every quadratic equation, I'm going to set my dependent variable to 0, and that will allow me to find my roots. That will allow me to solve for d. So I'm just going to write it out. Now, I know that the coefficient of my squared term in any quadratic, if I can factor it, I need to factor out that negative in front of my squared. And so I'm going to go ahead and do that, negative. Then that's going to leave me with d squared minus 5d minus 84. And if I want to, I can go ahead and FOIL that to double check that I've got that right. Now, as always, if I can factor this, then I'm looking for the type of factoring that needs to happen. I'm looking at what remains in this bracket here now that I've removed that common factor of -1. And I see that I'm left with a simple trinomial, which makes my life fairly easy because factoring simple trinomials is straightforward. I'm looking for two numbers that will multiply to give me -84, and I'm looking for two numbers that are going to add to give me -5. So I want you to pause the video and think about what those values are in this case, because they're going to be able to help us create our factors. So I'm thinking that this is -12 and 7. So -12 times 7 gives me -84, and -12 plus 7 will give me -5. So that works. So let's set up our factored form of our quadratic. So negative, I'm going to have my two brackets, d minus 12 in one, and then d plus 7, again, just utilizing the factors that I came up with to create my brackets. Now, you'll remember that in solving a quadratic, I need to set each of these brackets to 0 because one of these factors has to be 0 to make my left side 0. So I'm going to go ahead and do that. So I know that either d minus 12 is equal to 0, so d is 12. And my other solution is d plus 7 equals 0, so d would be -7. Now, here I have two solutions, and in a quadratic equation, more often than not, that will be the result. So now I need to evaluate, in the context of this question, what makes the most sense. So remember that distance is a horizontal distance. I'm going to go back a minute over here, and I just want to focus in on this right here. And in fact, I'm going to replicate it, and because I want to add on to it in a different sort of space. So there, I've replicated it. And so you'll remember that I'm really just I'm tossing this stone into a ravine. So presumably it's going to fall at a level that is lower than where I'm initially throwing it, right? But really, a parabolic function has this axis of symmetry, so I could also sort of think of this as a backtrack. So if I'm thinking that, this right here is my starting distance, then what I'm going to find is I'm going to find two roots, one back here and one over here where it actually falls. So the one over here where it actually falls would be represented by the d equals 12. And over here where is sort of the backtrack in time would be my d equals -7. So all that's really symbolizing with the -7 is, if I were to trace that parabola back, that's where that root would be. But of course, in the context of this question, he's not throwing the rock backwards. That's not going to happen. He's throwing it forward. And so the solution to this question lies in the positive value for d. And so I can say that therefore the stone travels 12 meters forward before it falls. And so we can also think about why it therefore can make sense that we can set this to 0, right? Because 0 is our the position of our dependent variable when we're solving for the other variable. So n represents a root, right? That solution represents a root, which would mean that the height, where is the height equal to 0? Right? So there we have our two solutions. There's a real-world problem that we may use to solve that might be solved using quadratic equations and factoring. Let's look at a second example. Okay, for this example, I've chosen something that looks a whole lot different than the last one, so that when you encounter them in the practice problems, you'll know how to start. So this one involves geometry and measurement. So I see here that I have a rectangle, and so reading through the question, it says, a rectangle has dimensions 3x plus 1 and 2x minus 5, and its area is 1150 square centimeters. What are the dimensions? So you may be saying, well, they've given me the dimensions. But I think what they're implying in this question is like, what are the numerical values of the measurement of the length and the width? So I would start with what I know already, which is that area can be found and calculated by saying the length times the width. And so what I'm going to do next is I'm simply going to replace each of the variables in here with the expressions or values given in the problem. So they're telling me in this question what the area is. They're saying the area is 1150 square centimeters. So I'm going to go ahead and plug that in, 1150. And now I'm given a length and I'm given a width. So I'm going to choose my length in this case to be the 3x plus 1. And my width to be 2x minus 5. And of course, for practical reasons, when I'm solving this, it really doesn't matter what I call the length or the width, except that I need to go and replace the dimensions back in the proper position. All right, so now you may be saying, oh, well, this is already set up in factored form, so I don't really need to do anything. I just need to, set this to 0 and set this to 0, and then I'm done. But I'm telling you, no, you cannot do that. And the reason that you can't do that is because I have this area here on the other side. The only time I can set each of these factors to 0 is when the other side of the equation is equal to 0. But since that's not the case, I can't really do that. So what do I have to do instead? Well, what I have to do is I have to expand these guys right here first, and then move this 1150 to the other side. And when I do all of that, I'll combine all of my terms to simplify. Then I'll be ready to go through the whole factoring business again. So I'm going to go ahead and do that. And so I'm going to encourage you to pause the video and do that for yourself, and then check in with me. All right, so I have 1150 is equal to, and I'm going to use my FOIL method right here. First outside, inside, last to multiply these binomials. So I would have 3x times 2x, which is 6x squared. I'm going to have my outside, so 3x times -5 gives me 15x. Now I'm going to do my inside. 1 times 2x is positive 2x. And then my last term is 1 and negative 5, which gives me negative 5. Now I'm going to simplify that. So 1150 is equal to 6x squared minus 13x minus 5. Now I'm in a position to go ahead and move this 1150 to the other side and subtract it. And that will give me what I'm looking for, which is a 0 on the left-hand side. So 6x squared minus 13x minus 5 minus 1150 will give me negative 1155. So this is not a although it is a simple trinomial, it's not a simple one to factor because the numbers are going to be quite large, right? So I'm looking for numbers that are going to multiply to give me the product of my first and last value, which happens to be negative. I'm not going to be able to fit this in, so I'm just going to move it over here. So blank times blank has to give me the product of my first and my last, which is negative 6930. But the values have to add to give me my middle term, which is negative 13x. Well, negative 13. And so, I fiddled around with my calculator and I came up with the following values. The values were negative 90 and 77. And so now I'm going to go ahead and use those values to factor this. So negative 90 and 77. Okay, I'm going to divide by the coefficient of my first term, which is 6, and then simplify. So I'm going to get a value of 15 here, negative 15, and then 77 over 6. And I'm going to use that to create my factors. So 0 is equal to. So in factor form, I'm going to end up with finally x minus 15 and 6x plus 77. So I'm just going to kind of make this a little bit smaller. Now I'm ready to equate each of these brackets to 0. So I'm going to go ahead and do that. So I know that either x minus 15 is equal to 0. So x is equal to 15. My other possibility is that 6x plus 77 is equal to 0, in which case I have 6x equals negative 77. So x is equal to negative 77 over 6. So now, again, I want to analyze my result here. Remember, each of these are representing centimeters and centimeters. So even if I go ahead and I get this into decimal form, I still have negative 12.8 centimeters roughly. In the context of this question, however, the negative 12.8 as my solution does not make sense because I'm talking about a length or a width dimension. So in this case, I can comfortably say that the value of x is 15 centimeters. So then going back, the way that I'm going to solve this is by simply substituting in the value that I gained for x, which is the 15 centimeters into each of these different dimensions. So when I go ahead and do that, I'm going to just draw out a rectangle here, and I sub in x as 15 for each of them. Of course, I'm going to have 2 times 15 minus 5. So 30 minus 5 gives me 25 centimeters. And then on my other side, I have 3 times 15 plus 1. So that's 46 centimeters. Now, if I want to check to see if this actually works, I would say, well, my area was supposed to be 1150. Does, in fact, 25 times 46 give me 1150? Well, let's just plug that into our calculator. And luckily it does. So there we have it. So if we're looking for the solution to this, the dimensions are that the length and width are 25 and 46 centimeters. All right, so that's the end of this problem. That's the strategy you want to use to solve it using quadratic equations. I'm hoping what you're thinking about right now is, well, what if the dimensions were not really nice, pretty numbers? How would I possibly factor a quadratic function that doesn't have nice, pretty numbers? Well, we know that it's difficult. We can't really factor quadratic equations that are not factorable and solve them. So we have to have another strategy, and that is coming next. So stay tuned.